I think it's useful to diagram out the logical content of a statement that you're trying to prove is that that logical content should be mirrored in the order in which stuff appears in your proof itself. So the statement you're trying to prove is that for all positive real numbers epsilon, we can find, there exists, a natural number n with the property that 1 over n is less than epsilon. And so the point I make in this short hints video that I want to make again quickly here is that because this statement begins with a universal assertion, right? The statement that we're going to prove is supposed to hold true for all epsilon greater than 0. That means that as a discoverer and a writer of proof, we don't get to control the value of epsilon. Somebody could come up to us on the street and hand us an epsilon, and we would have to use that one, right? We would have to show that this statement is true for that one. So somebody hands me the number 1.712 or something as my epsilon. I'm stuck with that. I don't have control over that. So as a proof writer, I have to show why that 1.72 has a 1 over n, which is between it and 0. But somebody else might hand me a different epsilon, maybe one that's a lot smaller, 0.006 or something, and then I'd be stuck with that one. So as a proof writer, as a mathematician, I don't control the value of epsilon. It's handed to me from on high, right? So I just have to deal with that fact. And that shows up as the very first line of my proof. Right? This is the proof writer making peace with the lack of control that they have over epsilon. Let epsilon greater than 0 be chosen. It doesn't say chosen by whom. It's not chosen by us. It's chosen by the hand of mathematical fate. Right? We don't have any control over what that value is. And so what we're about to write needs to be true regardless of what value epsilon has, as long as it's positive, real. Right? So we don't have control over that. What we do have control over is the value of little n. So we need to show in our proof that an n exists that satisfies this property. And so n we do have control. In fact, we're almost the architects of n. Right? We have the ability to create an n however it suits our purposes, as long as we can then show that that n meets this criteria that we're trying to show. So we get to be the ones that bring little n into being. We're not the ones that bring epsilon into being. Right? Epsilon is handed to us. We have to deal with it. And our job is to give an n that meets that criteria. So in the structure of the proof, there should be these kind of 3 phases to it. And the first phase is straightforward. It's just we're going to accept that epsilon is something we can't choose. So let's just let it be chosen, passive voice. But then the next step is we're going to define n. And you don't know yet, probably, maybe you did this work, but you don't know yet necessarily how you want to define n. But however we define n on this step, we're going to then need to convince the reader that that n also satisfies this last property, the one that's important, the one that's the conclusion of our proof. 1 over n is less than epsilon. So again, the logical content of the statement should be mirrored in the organization of the proof.